there are many firsts associated with the Solar Orbiter spacecraft. It will take images of the Sun closer than any probe before, and earlier this year, it took the first ever views of the Sun's south pole. Solar Orbiter is equipped with 10 science instruments whose observations will enhance our understanding of the Sun and the inner heliosphere. One of these instruments is called Radio and Plasma Waves, which has been developed by an international consortium led by Paris Observatory's Laboratory for Instrumentation and Research in Astrophysics, or LIRA. To find out more, I visited the Paris Observatory in Meudon to meet Milan Maksimovic, who is the principal investigator of this instrument and the director of LIRA. What is so special about the new views taken by the Solar Orbiter probe?
All the planets of the solar system, they are going around the Sun, more or less in the same plane, which is called the ecliptic plane, which means that for ages we have seen the Sun from the side, from the equator plane. So the other point is that the Sun is a star which is rotating on itself. It's not like a rock planet. It's a fluid. It's constituted of a gas. It's a fluid. So it has a fluid rotation. The equator of the Sun is rotating faster than the poles. That we know. It's called the differential rotation of the Sun. And because of this differential rotation, we have the creation of the magnetic field of the Sun through the dynamo effect. And up to now, all our spacecraft which have made images of the Sun, even from the Earth when we observe the Sun, we see it from the ecliptic plane. We see the equator of the Sun, but we don't see very well the poles. We know how the Sun rotates. We know the circulation of the matter around the equator and the medium latitudes. And by the way, we see that there is a rotation because of the sunspot. The sunspot, when we observe the Sun from one day to the other, we see the rotation because the sunspot moves on the surface of the Sun. But we don't know exactly the circulation of the matter around the poles because we don't see directly the poles. And Solar Orbiter is the first mission which will make images of the solar poles using cameras and measuring the motion of the matter on the so-called photosphere, which is the sphere from which the light is coming. So we are going to see the circulation around the poles, which is very important for some models, which purpose is to look at the deep interior of the Sun, to do heliosismology. And for that we need these special views of the poles.
Can you tell us about the Radio and Plasma Waves instrument?
The instrument is constituted of 3 parts: electric antennas, a magnetic antenna, and a main electronic box, which is constituted of very complex receivers. And LIRA had the full responsibility of developing the main electronic box. So the main electronic box was developed here, assembled here, and most of all tested here. It has been tested into the vacuum chamber facility that we have in the space center of LIRA. And this is very important to reproduce the conditions that you have in space in terms of temperature and vacuum. RPW is, as is coming from its name, radio and plasma waves, is an instrument which measures electric and magnetic waves in the plasma and also the radio emission which are caused by the Sun. This plasma constitutes something like 95% of the coronal matter that we have, the corona that you see when there is an eclipse. And this corona is so hot that it is creating the so-called solar wind. And the solar wind is expelling in all the directions of the inner heliosphere. And the solar wind causes, when there are some eruptions, for instance, on the Earth, aurora, the famous aurora that you can observe in the northern regions. And this solar wind, constituted of plasma, because you have protons and electrons, electric particles, when there is a motion of electrons in this soup, it creates special waves, plasma waves. And these plasma waves, we measure them with the RPW instrument. We measure them locally, but we can also measure them remotely when they are produced very far from the probe. For instance, when you have a solar eruption, which produces both light, matter, and also energetic particles. The sun is a very good energetic particle accelerator. It creates particles at very high energy, which, by the way, can be dangerous for the astronauts. For instance, if you have astronauts and they go outside the International Space Station, they can be hurt by these energetic particles when there is a solar flare. These energetic particles, you can detect them when they pass by the spacecraft. They enter the detectors and you can detect them. But you can also detect the radio waves that they produce when they are injected, for instance, on the other side of the sun. And we detect, thanks to RPW, eruptions and energetic particles, all of the eruptions and energetic particles which are produced by the sun, whatever is the direction of motion of the energetic particles. So we listen basically to the sun, and we listen to the radio waves of the sun produced by these energetic electrons.
Can you provide an overview of the Solar Orbiter mission and what are its objectives?
So the Solar Orbiter mission is constituted of 10 instruments that can be basically classified in two categories. They are the remote sensing imagers, remote sensing instruments or imagers, which make images of the sun, of the surface of the sun. They can measure the magnetic field. They can measure also the corona in different wavelengths, and the corona that is observable during an eclipse on Solar Orbiter can be observed permanently because there is a coronagraph, which is an instrument which creates a kind of fake eclipse, and you can see the corona all the time. And you can measure this corona remotely by these imagers at different wavelengths, and this is probing the corona in different temperatures. So these instruments, they are looking for some eruption on the sun. So when you have an eruption, you have a flare, a so-called flare, which produces photons. You have an enlightenment of a particular zone of the corona, and we image that with these instruments. And once the flare occurs, you have both energetic particles which are injected into the interplanetary medium, but you have also the so-called coronal mass ejections, which is a piece of the coronal atmosphere which is expelled at very high velocities, up to 2,000 kilometers per second. And this coronal mass ejection is then carrying the plasma. And then you have the second category of instruments for which you measure these in situ plasma by detectors. So you measure either energetic particles or the plasma itself. You can measure the composition of the solar wind. You can measure the density, the temperature, and the local magnetic field. So these are the second part of the instruments, the in situ instruments. And the novelty with Solar Orbiter, which was launched already in 2020, is that you have all these instruments on the same flat platform. In the past, we had to combine different observations from different viewing angles of the sun in order to have all this fleet of instruments and in order to have all these observations. With Solar Orbiter, we measure with the same platform from the same viewing angle all the information that the sun can send us. And Solar Orbiter is doing these measurements on an orbit which is quite elliptical. It goes from 0.3 to 0.8 astronomical units. And you can go as close as 0.3. And there you have the best images of the corona up to now with the best resolution ever, around 70 kilometer resolution per pixel, have been obtained at this closest approach. And the mission has already given many interesting results. But now with this new phase for which we are able to exit of the ecliptic plane, we will have even newer images of the Sun, and we will have closest approaches also of the solar poles.